All right, so at least you'll be able to see this. Okay, so that takes care of 3. What other questions, if any? Yes. Number 5. Yes, number 5. We definitely should go over. These true or false ones seem to be pretty easy, but they can be difficult.
I have a quick question.
Yes.
Can I work on some numbers?
For in here or out there? Yeah, that's fine. All right, number 5 says, given that B is greater than C, and yes, that is greater than, okay, determine whether the following inequalities are true or false. Justify your response. So, letter A, B plus C is greater than 2 times C. Is that true or is that false? I think I heard a true and I think I heard a false. Zion, what do you think? B is already greater than C. So if I say B plus C, is that greater than 2 C's, 2 times C?
Yeah. Wait, say it again?
It's right in front of you. Letter A, B plus C is greater than 2 times C. Nevaeh says true. What do you think, Zion? Do you know Nevaeh? I think you're new this year, right, to Pike? Yeah. So welcome again. I've welcomed you before. True. It is true. How do we know? Yeah, but I need more than just you to say because B is greater than C.
You got 2 C's. That's like saying C plus C.
Yes. Yes.
B is greater than C.
Right. So can I do this? Can I simplify this algebraically? What could I do to both sides that would give me an algebraic true expression? Shelton? Yeah, subtract C. If I subtract C, C goes away on the left. I get B is greater than 2C minus 1C is C. So subtract C from both sides. B is greater than C. That is given. So it is true. Okay. Anybody substitute some numbers in? Okay. You can also do that. So substitute numbers in. The only thing I will say about that is when you are doing this tomorrow, if you substitute some numbers in, you better use a couple of examples. Because in sometimes when you use a 0 or a negative, it might not work out. Yes?
What's that first word after the comma?
That is given. That being the B is greater than C. That is given, so it must be true. So if I substitute numbers, and let's say I let B be 4 and C, or B be 5 and C is 4. 5 plus 4, is that greater than 2 times 4? 9 is greater than 8. Yes, that checks off. But let's use some negatives and some zeros. Maybe I say B is 0 and C is negative 1. So is 0 plus negative 1, is that greater than 2 times negative 1? Negative 1 is greater than negative 2. Yes. So you can substitute some numbers. All right, letter B. 472 plus B, is that less than 472 minus C? I heard a false. Who said false or why? How do you know? Yeah. If you subtract, well, wait, let's go back here. If you add, please stop talking, add a value to 472, that should be greater than subtracting a smaller value from 472. So if you add a value, that's your B that we're adding to 472, that has to be greater than subtracting a smaller value from 472. Do you think that's true all the time? Anyone? Let me show you something, because I brought this up to Bieshke. I was like, that doesn't work for all numbers. Let's say I let B be equal to, I gotta make sure I get this right, 1, and let's let C be equal to a negative 2. And this is why I say you need to use some positives and negatives. So if I say 472 plus 1, I get 473. How does that compare to 472 minus a negative 2? You add the opposite and you get 474. In this case, it is less than 474. So in that case here, it would be true. But for most of our numbers, it will be false. Isn't that crazy?
Yeah, that is great.
I know. So be wary. Make sure you check in with some negative numbers and some zeros sometimes. All right, the next one, C, is BC less than C squared. True or false? False? Why? There's always that why. I answered the question. Why can't that be enough?
C squared.
Is what? You're right, but you got to justify it to me. You got to prove it. Why? That's what I'm asking you. Why? Because you guys could just guess. That's why. What could I do algebraically here to both of them? That would be the same on both sides. What could I do algebraically? I could divide both sides by C. And when I do that, if I divide by C, this C simplifies out. I get B is less than, what is C squared divided by C? C. And that gives me B is less than C. Is that true? No. Divide both sides by C and you get B is less than C. But we know B is greater than C, so that is false. We were given this. This is what we were given. Okay? All right. Questions on C? Oh, say, can you see? See? I'll just do that weird stuff every once in a while. Letter D. What about 1 divided by B? How does that compare to 1 divided by C? This says it is greater than. Is that true or is that false? False. Why? Yeah. And? Yes. Yes. If B is greater than C, which is what we are given, you want 1, let's say we're talking about gold. So you want the largest piece of gold that you can get. Would you rather have 1/100th of an ounce, or would you rather have 1/25th of an ounce? this is going to be the larger number, okay? So 1 over a larger number results in a smaller fraction, okay? Something like that. And 1 over a smaller number gives you a larger fraction. All right, and the last one on this section, 100 divided by b squared. How does that compare to 100 divided by c squared? True or false? Is 100 divided by b squared going to be larger? So let's say b is equal to 10 and c is equal to 5. If you want the larger piece, would you take 100 divided by 100? Or would you take 100 divided by 25? Which one's going to get you the larger? The second one, right? So this one is larger. They are showing the first one is larger, so this is false. So the same number divided by larger number is smaller than the same number divided by smaller number. Okay? It is a little tedious when you are writing down the justifications. It can be. Okay? Other questions on this review? Have we covered every, let's just do this one. I don't even know why this one's separate. It's a lot like what we just did. Which of these expressions is larger, s squared plus 6 or negative 3 plus s squared? On number 6, which one is larger? Brady, which one's larger? Yeah, why? How do you know? Adding 6 to the same number is going to be greater than subtracting 3 from the same number. Okay? Don't just say because 6 is greater than 3 or, give me a little bit more there. All right. What about factoring? Number 8, should we go over that really quick? Number 8, GCF. You have 3x plus 21. What is your greatest common factor there? 3. So when you divide by 3, that 3 comes out front. 3x divided by 3 leaves me with x plus 21 divided by 3 is 7. So 3 times quantity, x plus 7. Letter B, what's your greatest common factor? 3, again. So pull that or factor that 3 out front. 9x divided by 3 is 3x plus 21 divided by 3 is 7. And the last one, negative 2x minus 12. What's your greatest common factor there? Negative 2. Yes, make sure if the first term has a negative, that you factor out the negative. So divide by negative 2, that's your greatest common factor. Negative 2x divided by negative 2 is first term.
I'll wait for
X, and negative 12 divided by negative 2 is 6. And if you're not sure, go back and distribute and make sure you get your original expression, right? Negative 2x minus 12. Boom, I know this is then correct. Questions on any of those? Someone beating their chest? Okay, we only have a couple more to go, and I do have one more example of finding the nth figure that I would like you guys to try. But first of all, number 2, what's the final answer of this type of area written as a polynomial expression? A polynomial expression means it's going to have plus or minuses in between. In other words, a sum of your areas. So what is the area of this first figure? 27x. What is the what is the area of that figure? 45. And so the sum of my areas, or the polynomial expression, would be
27x plus 45.
And what about letter B? What's going on here? What am I actually doing here? Yes, say it. Yes, and you're basically trying to find a GCF. Now, somebody in the last class said, well, what if I did 2 here? It's not the GCF, but it is 2. Would you take that? It does work. I would prefer you go for the greatest common factor. So what is the greatest common factor of these two? 4. So factor out the 4. 4x divided by 4 is x. 28 divided by 4 is 7. I have to write my final answer as factors, so that would be 4 times x plus 7. Yes. It does work, but this is better answer. So you probably will get partial credit. Partial. That's what I'm saying today. All right, let's quickly go over these. I mean, we might as well, right? Letter A, how do you simplify those expressions? What do we have to follow? PEMDAS or PEDMAS, right? I don't know why they said PEMDAS. I mean, why don't they say PEMDAS or PEDMAS? It's just wrong. Remember, if you can do what's in parentheses, please do that first. Don't start distributing. That's where a lot of you get in trouble, because you'll get probably an incorrect answer. But here, parentheses first, that is 2, and do 1 operation per line. That's what I think is best. I have multiplication, addition, subtraction, and multiplication. So I would do 3 times 5, 15 plus 2 minus 7 times 2. I would do this next. Plus 15. 17 minus 14 gives you 3. Letter B, help me simplify letter B. What would you do here? Can you add y to z? 1z, 2z, 3z, yz? No? You cannot. So what would you do here? This is not an equation. There's nothing to divide here. If I want to simplify this, what would I do? I can't hear. Multiply, yeah, distribute. X, with each of these on the inside, you get x times y plus x times z plus y by itself. Why didn't I multiply x with that y? It's not in the parentheses. Can I simplify this anymore? No, so that is your final answer. And the last one. Again, do what's in parentheses. That's a 4 plus, put everything else the way it was. 6 minus 4 plus 4. 2 plus 4 is 6. All right, so that is all the problems. I want to very quickly show you another problem that talks about finding the nth figure, because we did that yesterday. Oh, Shazbad. Hopefully you didn't. No, you didn't see that. Good. Here is my figure. So I have a figure 1, I have a figure 2, and I have a figure 3. I want to know how many squares would be in the fifth figure. And you're right. The fifth figure, you could draw it out, okay, because it's close enough. But what if I said the 10th figure? You would not have time to draw them all out to the 10th figure. So everybody focus on this for just a couple of minutes, and let's see if we can find someone who can tell us how we can figure out the number of tiles in the fifth figure and the number of squares in the nth figure. What? It's what? They go up 4 each time. Oh, did you hear what he said? He says these squares, and what do you mean they go up by 4 each time? So figure 1 has 3 squares, you're saying, right? Figure 2 has 2, 4, 6, 7 squares. Figure 3 has 2, 4, 6, 8, 10, 11 squares. So he notices they're increasing by 4 each time. Okay. And what I told you guys yesterday is you always need to base it on the figure number. So just to check, I would probably try my own and do one more and say figure 4, is figure 4 going to follow that same pattern? So I have 1, 3, 5 in the middle. So this one's going to have 7. 1, 2, 3, 4, 5, 6. It's going to have 4 closed in up here and 4 closed in down here. Okay. And does that give me plus 4? Does that give me 15? Yes, it does. So how many would be in the fifth figure? 19. How many squares would be in the nth figure? Have you found any kind of a pattern? Take a look at your figure number. How does that compare with the total? How do you get from figure 1 to 3? Layla? Adding 2? Well, that works for the first one, but if I add 2 to figure 2, that only gives me 4, and I need 7. How can I get from 1 to 3? It's an increase, right? So you're either going to be adding or maybe multiplying. So 1 plus 2 doesn't work. 1 times 3, 2 times 3 is 6. That doesn't work for that one. What about 1 times 4? Gives me 4, and then I subtract 1. What about 2 times 4? Gives me 8, subtract 1. 3 times 4. So the nth figure would be whatever n is, 4 times n minus 1. So that's what you need to ask yourself on some of these, okay? I did have, very quickly, someone said that the number of gray tiles was always 2 times the figure number. And then someone said the white tiles were always 1 less than the gray tiles. I should say gray tiles minus 1. So they found it that way. So if I find my gray tiles, 2 times n, my white tiles would be 2 times n minus 1. Add those together, 4n minus 1. Test tomorrow. Make sure you're ready. Be ready. It's going to be more challenging than you think. So look over your workbooks. And I'll be here tonight after school. Oh, shoot. I should have taken attendance. Ooh. Yeah, that's one. Nackney, I think is her name. She's new. Oh no, I didn't take third either? Oh, that's bad. Brendan Ludini, Alex Jesman, Abel. That's right? That's the one that counts. Layla, Rayshawn, Ibrahima Brady, Lay, Lyndall, Diana, Nackney, Jacoby, Ashley, Tori, Linda, Sean, Teresia, Roy,